the acids and bases portion of this unit. So looking at your acids and bases, the last thing that we're going to do is we're actually going to calculate the pH of the solution. There's actually something called pH and POH, so we're going to look at both of those. But looking at just your pH first, it is a mathematical way of figuring out the hydrogen ion concentration so we can have a number that we can compare. So we're looking at how many hydrogen ions are present. And when we look at how many hydrogen ions are present, it's on a logarithmic scale. So looking at that logarithmic scale, if you go from like a 2 to a 3, that means that it's 10 times stronger. If you go from a 2 to a 4, you'd have 100 times different in between there. So looking, I said stronger from 2 to 3, that would be weaker. Sorry, I just realized what I said. So anytime you go from one number to another, it's 10 times different. So your actual definition of the pH is the negative log, or logarithm, of the hydrogen ion concentration. The H right here means hydrogen. The P, people in the US say it's power, it's pouvoir from French, but it is a logarithmic scale looking at the hydrogen ion concentration. The more hydrogen ions you have present, the more acidic something is. The fewer the hydrogen ions that are present, the more basic it is. So you have this sliding scale between 0 and 14 of your pH scale. 7 is neutral, and then when you have your acids and bases from there, depending on what the number is. So looking at your pH scale, again, it was a French person that decided that we needed some type of a scale to use this. He used a logarithmic scale to give us easy numbers to deal with, but it is the power of hydrogen, or pouvoir, and that is just how many hydrogen ions are present. So looking at our pH scale, we are going to mathematically determine a number between 0 and 14 to figure out if something is an acid or a base, or neutral if you're exactly at 7. So looking at this pH scale, in the little graphic here, again, a 7 is pure water. That would be like distilled water. And then if you have anything bigger than the number 7, so bigger than the exact number of 7, so if 7.0000001 is a base. So bigger than 7, you have a base, so you go from like a 7 to an 8, or an 8 to a 9, 9 to a 10. If you jump a few of the different spots here, you would multiply by a factor of 10 each time. So if you go from a 7 to a 9, that is actually 100 times more basic than one to the other. So you'd have 1,000 times, 10,000 times, and so on and so forth. So looking at your acid end of the spectrum at the top up here, that is anything that is less than 7. So bases are bigger than 7, acids are less than 7. So anything less than 7, you would have an acid type compound, and that goes all the way down to 0. Now looking at this scale, when you're at a 7, that is neutral. The further you get away from the number 7, the stronger the acid is. Or the further that you get away from that number 7, the stronger the base is. You can have on each end of the spectrum just as dangerous or just as acidic or basic as each other. So if you have a pH of 14, that is liquid drain cleaner. You put that in your drain and it eats away all the hair and the organic matter that's in there. So that can do just as much damage as something like battery acid that has a pH of 0. So on each end of that spectrum, you can have very dangerous acids. You can also have very dangerous bases. The closer you get to the number 7, the more neutral that they are. So when we're looking at our pH scale, again, I just went through this. Anything that is greater than the number 7 is a base. Less than the number 7 is an acid. So bigger than 7 is a base. Less than 7 is an acid. And if you are exactly at 7, exactly, that's neutral. Anything less or more is an acid or a base. Now we also have a POH scale, and you actually don't hear about the POH scale very often, but it's kind of the flip side of your hydrogen ion concentration, which is your pH. Looking at this, it's the negative logarithm of the hydroxide ion concentration. So we take how many hydroxide ions are present, and we can figure out the pOH. When we have the hydrogen ion concentration, we figure out the pH. So working together, your pH and the pOH are always there together. When you add the two numbers, you get the number 14. So that means that if you have a pH of 1, your pOH is 13. If you have a pH of 7, your pOH is 7. If you have a pH of, I don't know, 8, your pOH is 6. So no matter what, when you add your pH and your pOH, the number that you're going to get there is 14. So how we solve for this, you have two different formulas here depending on if they give you the hydrogen ion concentration or the hydroxide ion concentration. The little brackets here, you're going to find out in the next unit, these little brackets mean concentration. So that's a fancy way of writing the molarity. So you have the hydrogen ion concentration, you're going to take the negative log of that. You also have the negative log of the hydroxide ion concentration, again, depending on if they give you hydrogen or hydroxide. Now the negative button on your calculator, you need to make sure that you are pushing the negative key, not the subtract key. You want to push the negative key down here. And if you have the other type of calculator, it's at the bottom as well. So you're going to push negative log. And it'll usually pop up parentheses automatically. You're going to put in the concentration, you're going to close up your parentheses, and that's it. So when you're solving for pH or pOH, they're actually pretty straightforward. There's just a few things that you need to remember. So when we are looking at your, I totally spelled that wrong. I will fix that in a second, sorry. When you're solving for sig figs, the 14, if you ever have to subtract from 14, that does not go into your calculation for sig figs. So you always want to make sure that you are looking at your other number, the concentration, because that's your measurement. 14 is not a measurement, it's a standardized number, so it has an infinite number of decimal places. So in our example here, we have two different concentrations, and it wants us to find the pH and the pOH just so you can see the difference between them. Normally you wouldn't have to solve for both of them. So I'm going to switch over to my document camera here. I have my calculator ready to go, but it asks me to find the pH and the pOH. So if I'm looking for both of those, you have a few things that you need to remember. First, you have the negative log of the hydrogen ion concentration. That's going to give you the pH. Hey, look, those match. The negative log of the hydroxide ion concentration is going to give you the pOH. And then something else just to keep in the back of your mind, pH plus pOH is equal to the number 14. So looking at our first practice problem, it says that we have 0.0125 molar hydrochloric acid. So with this one, we want the pH and the pOH. This is my concentration. So when I plug in negative log of 0.0125 and get an answer, that answer is going to give me my pH. I know it's the pH because this right here has hydrogen. That will match. This has hydrogen, that gives me the pH. This number right here, before I even plug this in my calculator, has 3 sig figs. So my pH is going to have 3 sig figs. So when I plug in this number, I'm going to push negative, and then log is over here on the side on my calculator. So negative log 0.0125, close up my parentheses. This number needs 3 sig figs. So you get 1.90, because the 3 makes the 0 stay the same. That's 3 sig figs. Now, this also asked me for my pOH. So if I needed to get my pOH on this one, I'm going to use this other equation where we have pH plus pOH is equal to 14. So in this, we're going to plug in 1.90 plus my pOH is equal to 14. So I need to get the pOH all by itself by subtracting this off of both sides. So I don't need a calculator for this, but I'm going to just show you the math anyways. So you take 14 minus 1.90. This number right here, the 1.90 is my measurement. It has 3 sig figs, but that doesn't really matter because I'm subtracting. When you're subtracting, you look at decimal places. So when we subtract these two, this number, the 14, has an infinite number of decimal places. This number has 2, so that means that my answer has to have 2 decimal places. So when I write this, you have 12.1 is what my calculator says. This is why I wanted to show you this, but it's 0 because I have to maintain those 2 decimal places. Adding and subtracting, you look at decimal places. When you're doing multiplication and division, you look at your sig figs. So my POH is 12.10. Again, normally it doesn't ask you for both, but it was just easier to show you the same problem with both of them. Now in this one, again, I'm going to take the negative log of 0.250. Now when I plug this into my calculator, this answer right here is going to give me my POH. I know it's POH because right here I have a hydroxide in my formula. So if it doesn't say like this is the hydrogen ion concentration or this is the hydroxide ion concentration or whatever they're giving you, you have to look at the formula because I have hydroxide. That's going to give me my POH. So again, we're going to take our calculator, negative log of 0.250. When we get the negative log of 0.250, this has 3 sig figs, so my answer is going to have 3 sig figs, 0.602. That's going to give me the POH, so that's the first answer. Now it's also asking for the pH, so in order to get that, I'm going to take my pH plus my POH, that's equal to 14. When I subtract this off of both sides, again, I'm going to use my calculator just to show you what it says. I really don't need it, but so my calculator screen actually shows me 3 decimal places. This number has 1, 2, 3 decimal places. So I'm going to write down all of those decimal places. So 13.398 is my pH. pH plus POH equals 14. So when we look at these, again, typically it only asks you for one or the other, but in case it does ask you for both, like I said, I just went through that process. But these are pretty straightforward. They're very nice because they don't have any units. There's no unit for pH. It's just a way of comparing 2 numbers to one another. So when you are doing the math, you have to show your work. You're going to use the correct answer or get the correct answer, and you're going to use the right number of sig figs, but there is no unit for pH. So if you guys have any questions, make sure you ask. Otherwise, I hope you have a great day.